For question number 1, the shape that cannot be a cross-section of a cone is number 1, the square. A triangle you can definitely get because as you can see, the face is triangular of a cone. You can get this curved shape, as you can see. We can get it from the cone. And we can get a oval shape because that's what the base is. So answer choice 1 is the correct answer. In number 2, we're talking about a cross section that is perpendicular to the base. So I'm just going to draw a prism, and I can't draw a hexagon. Let's just imagine that's a hexagon. It's not, but I can't draw that. So imagine that's a hexagon. So if we were cutting parallel to the base, it would be the same as the base and it would be a hexagon. But we're cutting perpendicular to the base. So if we're cutting perpendicular to the base, it's going to be the same as the face, and it is going to be a rectangle. In number 3, to find the volume of this triangular prism, it is area of the base times the height. So the height of the entire prism is 10. So 10 is what's going to go in for the height. The area of the base is the area of this triangle, and area of a triangle is 1/2 base times height. So area of this triangle would be 1/2 6 times 4. So I'm going to put that here, 1/2 6 times 4 times the height of the whole prism, which is 10. 6 times 4 is 24, half of that is 12, times 10 is 120. So 120 cubic inches is the volume of this curtain. In question number 2, they give us that the slant height is 17 inches and the diameter is 16 inches. If the diameter is 16 inches, that means this is 8. We need the actual height of the cone. So you can find the actual height of the cone using the Pythagorean theorem. H squared plus b squared equals to 17 squared. And if you continue solving for b, we have that b is equal to 15. So volume of a cone is 1/3 pi r squared height. So that is 1/3 pi h squared 15. I'm going to put just the numbers into my calculator. So I'm putting in 1/3 h squared times 15. And I got 320 pi inches cubed. Moving on, the square cannot be a cross-section of the cone. All the other ones you're able to get out of a cone, but not that one. For number 4, we have a rectangle, and we're rotating it around the longer side. The rectangle is 6 by 5. And if I'm rotating around the longer side, we're spinning around and around and around, and eventually the curved part is going to look circular, and it's going to look like a cylinder. I'm a terrible artist, but it's going to be a cylinder oriented on its side like this one, as you can see. And as you can see, the height is 6, and the radius is 5. So it's a cylinder with a radius of 5 and a height of 6 inches. Here we are taking a cross-section perpendicular to the base. Perpendicular to the base would be this way, which would be a triangle because the base is on the bottom. So parallel to the base would be the rectangle or the square, but perpendicular to the base is the triangle. Here, we know that the base area is 36 centimeters squared and the height is 10 centimeters. The volume of any pyramid is 1/3 capital B times H. Capital B is the base area, which we already know is 36, and the height is 10. So the units here are all centimeters, so my volume is going to be in centimeters cubed. So let me just multiply these in my calculator. And I got 120 cubic centimeters. Now they also tell us what the density is. And notice that the volume unit for the density is already in cubic centimeters. So far, so good. So we have 2.7 grams per cubic centimeter, that's the density, is equal to mass, which is what we're finding, over the volume, which is 120 centimeters cubed. The centimeters cubed cancel out. So when we cross multiply, our mass is going to be in grams, which is the way we want it. Let me do on my calculator, 120 times 2.7. Oops, I clicked the wrong buttons on my calculator. And I got 324 grams. No rounding was necessary here. In number 7, we have a snowman made of 3 spherical snowballs, and we need the amount of snow, which is the volume in terms of pi. That means a pi in our answer. So I'm going to need 3 volumes here for each of the spheres. Let me actually plug in. So for the first snowball, the radius is 1. For the second snowball, the radius is 2. And for the third snowball, the radius is 3. So here we have just 4/3 pi. Here we have 2 to the third power is 8. So 8 times 4/3. I'm going to do that in my calculator. 8 times 4/3. And it gives me a really long decimal, but if you hit math, enter, enter, it will change it to you as a fraction in lowest terms. So as a fraction, that is 32/3 pi cubic feet. These are all in cubic feet because all the measurements were in feet. And in the next one, 3 to the third power is 27. So I have 27 times 4/3. And that works out nicely. That just gives me 36 pi. So all I need to do is add these together. 4/3 pi plus 32/3 pi plus 36 pi. So let me type these into my calculator. I'm going to type in 4/3 plus 32/3 plus 36. And it works out to a very nice number. It works out to 48 pi, and that's in cubic feet. Over here, we do need to use Cavalieri's principle to explain why the volumes are the same of the 2 stacks of quarters. So you do need to use the context of the question, which means you have to mention the quarters. Otherwise, you're not fully answering it. Since both of these stacks of quarters have an equal amount of quarters, and I'm just going to put that there are 23 in each, they have the same height. Since quarters all have the same radius, the area of the base, which is the quarter, which is a quarter, will be the same. If 2 solids have the same base area and the same height, they will have equal volumes according to Cavalieri's principle. It doesn't have to be worded exactly like that, but you do need to mention same base area and same height, and you do need to use the context of the question. You do need to mention the quarters in there. Okay, for the next one over here, we need the volume of 100 candles. The candles are just the cone. It says the candles are in the shape of the cone. The rest of it is the mold. So we have 1/3 pi r squared height to find the volume of a cone. Be careful here, the diameter is 3. That means that the radius is 1.5. And the height is 8 for each of the candles. Let's put this into my calculator. I'm going to type in 1/3 pi 1.5 squared times 8. And I get a number, and I'm just going to write a couple decimals, but I'm not going to get rid of it from my calculator yet, because it's not my final answer. Remember, do not round early. It will change your answer. We need the volume not just of one candle like we have here, but of 100 candles. So I do need to multiply that by 100. And now when I multiply it by 100, I can round according to the question, which is to the nearest cubic inch, which is the nearest whole number. So it is approximately 1,885 cubic inches. For the next one, it says that Walter is buying wax. The wax is 10 cents per ounce. The weight of wax is 52 cents. Oh, sorry. The weight of the wax is 0.52 ounces per cubic inch. So this is the density. Because there are two units, there is the mass unit and there is the volume unit. So we are given the density, and we want for 100 candles the cost of the wax. So here is our density, ounces per cubic inch, and we're finding our mass. And here is our volume. And keep in mind, this is the volume for 100 candles. So when we find the mass here, that's already going to be for 100 candles because this was the volume for 100 candles already. So the cubic inches cancels out, which is good because our mass will be in ounces when we cross multiply. I should have put this as an M for mass. Oops, let me rewrite that better so I have more space. Let's see how many ounces. I'm going to do 1,885 times 0.52. And I got 980.2 ounces. And then I do need to multiply by the cost because it is 10 cents per ounce. And it cost Walter $98.02. Oops. $98.02 for the wax for the candles. Now, Walter spent a total of $37.83 for the molds and charges $1.95 for each candle. And we want his profit after selling 100 candles. So first we need to know how much he made. So Walter made $1.95 for each of the 100 candles. So Walter made $195. Now, Walter spent money on the molds, and Walter also spent money in part 2 on the wax. Both of those went into making the candles. So Walter's profit is what's left over from his $195 when you factor in the cost of the molds and the cost of the wax. And that is $59.15. Okay, for the next one over here, we have 2 cans of soup. The first one is a cylinder. So the volume formula is going to be pi r squared height. So it says the diameter is 7. So the radius is going to be 3.5 and the height is 9. So the volume here, the question does say the round to the nearest cubic centimeter. So we are rounding 3.5 squared times 9. And to the nearest cubic centimeter, that is about 346 cubic centimeters. Now, the next can of soup is also a right cylinder. That just means the cylinder is standing up so that the base forms a right angle with the face. The radius here would be 4.9 because the diameter is 9, 4.5 because the diameter is 9, so that's half of that. And the height is 13. I'm going to type this into my calculator as well. Pi 4.5 squared, 13. And I got about 827 cubic centimeters. Now, the next part is saying what's the minimum number of small cans that must be opened to fill the large container. So the large container was 827 cubic centimeters, and the small one is 346. So let's divide them. And that is approximately 2.39. A lot of people put 2, but the thing is, if you only open up 2 cans, then the large one container is not completely filled. It doesn't say that you have to put a whole can in there. It just says that must be opened. So you would need to open 3 cans to have enough to completely fill. And then you don't have to use the rest of the third can, right? You can put the rest away and use it a different time, but you got to open it in order to be able to fill the large container. And it does say that must be opened. For over here, we can take a look at the extra credit question number 1. And if you take a look at the names of the triangles, it tells you what corresponds. So AE is the first and third letters, so it corresponds to AC, which is not what you might expected at first. So AC divided by AE would give us a scale factor of 1 for one pair of corresponding sides. AC is 8.22 plus 4.1, so that is 12.32. So 12.32 over 5.6. And that is 2.2 for the scale factor there. Now for AB, AB is the first 2 letters, so it corresponds to the first 2 letters, which is AD, which once again is probably not what we would have thought. So we have AD over AB. AD is 5.6 plus 3.42, which is 9.02. So that is 9.02 over 4.1. And that is 2.2. So they are proportional. And we do have this congruent angle in between. So we do have SAS. It does say explain, so I do need words. So I'm going to put some words over here because I'm only graded on what's in my explanation if it's an explanation question. Since 2 pairs of corresponding sides are proportional by a scale factor of 2.2, and since the included angle, remember that means the angle in between, the included angle A is congruent to itself by reflexive property, the triangles are similar by SAS. Okay, over here we're making a parallel line, so I'm just going to get my compass up on the screen. Let me go get it because it likes to go on the top over there. So let me take my compass and drag it down. Okay, so when we're making a parallel line, the first thing that we need to do is make a transversal. Now your transversal just needs to go through the point C. And I recommend that you make it slanted. If you make it straight up, your construction is going to be more difficult for no reason. Okay, so what we're going to do is we're copying this angle to where angle C is at. So the first thing I'm going to do is I'm going to put my compass on the vertex of the angle that I'm copying, just the regular copy and angle construction. It just looks a bit different. Okay, I'm going to open up any distance, it doesn't matter, and I'm going to make an arc. And then whatever distance I used, I'm going to come up to point C, and I'm going to use the same distance. And I'm just going to make sure that I extend a little bit so I don't have to remeasure later, because sometimes I don't extend my arcs long enough. Okay, now I actually have to measure this angle. So I'm going to put my compass on each of the places where that reference arc, that first arc, hit the angle. I'm going to try as best as I can to match it up. Oops, I think I can get it a little bit better. There we go. And I'm going to just make a little arc to show that I measured. Ooh, oh no. Let me change the color there. 1 second. Oh, that's not matched up good. Let me try to get that a little bit more accurate. You'll be a lot more accurate than I am because on this computer program here, it's very hard to make accurate constructions. There we go. That's much better. Okay. Now, after I measure that and make that arc to show I measured, I'm going to put my compass point up here where that first arc hit the transversal, and I'm just going to make the same arc. And now the only thing left to do is to make your parallel line to the original one through this intersection point, and it should come really close to passing right through point C. Also, if you did this correctly, this is the part that I'm the worst at. Oh, I did that good on my first try. And notice there, we have a line that is parallel to the original one that passes through point